Hello, I hope all of you are fine in these extraordinary times. Well, 3D printing has been around in our country for the last 10 years. I was a bit frustrated that the interest was very slow to build up. Nobody seems to show significant interest, well, until this COVID pandemic, where we saw how 3D printing became a novel tool in our common battle against the pandemic. In 2001, while watching Jurassic Park 3, my attention was mesmerized in a gizmo that was shown in the movie, which they called a rapid prototyper, as they named it at the time. Sometime in 2007, they gave it a generic name called a 3D printer. Since then, I would grab anything I could read about this dream toy, becoming number one wishlist in my mind. I had a lot of explaining to do to my wife when I bought my first 3D printer in 2012. It was a non-essential. It was not cheap. You cannot eat it or cook food with it. It will occupy space in the house. But nothing beats having the bragging rights of being one of the very first few souls in the country to own one in 2012. The purchase was actually meant for designing and fabricating drones, which was a little hobby of mine at the time. Well, when drones were not yet available at Lazada and Shopee. Things really got worse and my wife really got angry when our house started getting filled with, 3D printed characters and stuff like this. Well, I really discovered that my purchase was not all in vain when we lost this part of our very expensive spine endoscope. There was no more available part for the older model that we owned, and having it machine fabricated was very expensive as well. That was when I realized that 3D printing would be a very useful solution to replace the lost part of our spine endoscopes. We never found the lost connector, but we have printed several dozens of these replacements, which we use up to now, and which we can print several times over. Our do-it-yourself printing also allowed us to come up with these 3D printed tubes of different lengths for our minimally invasive spine surgery. Little did we know that this technology is going to push us beyond the limits of our imagination. We were also able to modify our design in such a way that we were able to incorporate and isolate the fiber optics of our scope to protect it from damages, unlike the original metal tube that we had, wherein the spine fiber optic was exposed. 3D printing allowed us to develop various lengths and diameters we needed for our variations in our surgeries for different body builds of our patients as well. 3D printing also allowed us actual parts production, which when assembled give us an external fixature which have been used in disaster relief operations already, like during the Haiyan tragedy in 2012. It was also very useful in quick prototyping to come up with this 3D printed external fixation device, which we tested biomechanically and have seen that it works strong enough for loading to be used clinically for distal forearm fractures. And of course, just last year, at the height of the pandemic, 3D printing allowed us to fabricate various life-saving attachments and connectors that are not commercially available to allow us to attach ordinary swimming goggles into respirators to deliver air for patients suffering from severe COVID in our intensive care units. Going back in 2012, our biggest challenge before was how to convert DICOM images into STL files. There were no instructions available, nor YouTube tutorials at that time, since printing anatomic models was a big monopoly of industries. CT scans and MRIs will give you all the DICOM images we need for our patients, and we painstakingly figure out on our own how we can convert this into STL files. We downloaded every possible DICOM reader that was available in the internet at that time and carefully studied how we can convert our DICOM images into STL files. By the end of 2012, we were the very first in the country to be printing anatomic models from the DICOM images of our patients. Nowadays, anatomical modeling can be done in your clinic, call room, or even your department office with a simple desktop 3D printer simply by converting CT scan and MRI images into STL files, which is the universal language of 3D printing. Any file converted to STL will be read by a 3D printer and thus can be printed into a three-dimensional object or model. It's simply a matter of converting our patient's DICOM file into STL files that allow us to come up with perfect 3D printed anatomic models of our patients that give us normal and pathologic models which are case-specific to the patients we will be treating. Since 2014, we have been using 3D printed models in our center to plan and orient our residents in difficult spine surgeries we need to perform, giving them sufficient preparation before the actual surgeries. 3D printed models are very accurate 1:1 scale replication of any region of the part of the skeletal system we wish to treat, which shows in detail the osseous deformities we will be encountering during the surgery. 3D printed spine models are very case-specific, with very fine details and reveal the anomalies we wish to address. They are very good for patient education, as well as surgeon's orientation, which impacts very well on training and even the surgical practice of our residents. These models can be machined, drilled, cut, and chiseled, making them very good for practice surgery, with the biggest advantage that our model contains the pathology you will be actually operating on. 3D printed models allow us exact screw and rod measurements, meticulous pre-contouring of our constructs, which translates into saving vital time in our actual surgeries. This vital time translates into lesser exposure time, lesser bleeding, and even lesser infections. From these anatomic models, we felt and imagined that we can go a bit further, particularly in areas where surgery is very difficult, like the cervical spine. Well, particularly because my specialty is spine surgery. We will always want to place our spine implants along safe, bony corridors called the pedicles of the spine, away from the delicate spinal cord, nerve roots, and this vertebral artery which navigates the cervical spine. Because minor miscalculations can create catastrophic results when our screws are misdirected. So we asked ourselves in 2013, can we do our own do-it-yourself templating? Well, probably yes, if we develop our own program application for templating. But is there an easier alternative, while we cannot find someone yet who can create an application for us? By then, we were already confident that by using a simple tabletop 3D printer, we can produce an exact biomodel of our patient's spine. Patient-specific 3D models already enabled us to plan the exact extent of our decompressions to release our compressed spinal cords and nerve roots, like in this particular patient, whose spinal cord is compressed as it exits the skull in the foramen magnum. We want to go further, by using our biomodels to allow us precise placement of our spine implants. So, we started to print drill sleeves for the cervical screws that we use in our surgeries to stabilize the spine. Then, we incorporated the printed sleeves on the guide wires, which we carefully applied over our printed models in the manner we wish the screw to be safely placed in the pedicles of our spine. Then, we molded fast-setting dental acrylic cement over the posterior elements to incorporate the pin and the drill sleeves to create our own blend of a patient-specific drill guide. Shown in the screen are our finished templates. Our drill guides were given specific orientations, right and left, top and bottom, to prevent any confusion intraoperatively when we apply them over the specific level that we're going to operate. For example, this is for cervical spine number 2, and this one is for cervical spine number 3. Intraoperatively, we were able to appreciate our familiarity with the patient's anatomy from our 3D printed model, enabling us to perform a decent and exact decompression of the foramen magnum with just the right amount of necessary exposure of the operative field. Here, you can see that the space has been exposed and our drill guide templates are being tested for a snug fit over the laminate of the spine, where we will drill through the corridors of the spine pedicles for our screw implants using our handmade patient-specific drill guides. Our hand-molded patient-specific drill guides, once snugly fitted, allowed us to precisely direct our drillings to create the channels into the very narrow pedicles of the spine where we intend our screw implants to be applied, in this example at the levels of C2 and C3. By using these drill guides, we are very sure that our screw placement will be very, very precise. Our rods were also pre-contoured and pre-bent using our 3D printed models before the surgery, thus saving us, in this specific example, some good 45 minutes from measuring, cutting, and contouring if done intraoperatively for a perfect construct of our instrumentation. This time savings prevents significant blood loss and time exposure that matters a lot in infection control in very difficult surgeries like this. Fluoroscopic check showed us that we achieved our intended bony purchase to add stability to our construct with all our implants exactly where we desired it to be. Clearly, 3D printing has helped us in performing very difficult surgeries with precision and almost half the time needed to perform it in the conventional manner. We have published our novel technique in an international peer-reviewed journal, and this has received 24 international citations as of the moment, from various journals and manuscripts dealing with 3D printing and its utility in medicine. This is another example of a patient with a severe congenital scoliosis that we have to operate, where we felt that 3D printing is a critical tool to accomplish our desired surgery. These preoperative 3D models, printed from our patient's DICOM images, allowed us to plan our surgery very, very well. Weeks before we operated on the patient, we have touched, felt, planned, and mastered our game plans for the actual surgical procedures that we're going to do. Again, 3D printing made our surgery precise, faster, and a lot easier, and very, very safe for our patient. 3D printing is slowly becoming a mainstay in the operating room nowadays. It gives the surgeons increased confidence because it enables us to plan our surgical interventions very well. Currently, the applications of 3D printing for medical applications are as follows: anatomical modeling, patient-specific templating, instrument design and prototyping, actual instrument production, customized exo and endoprosthesis for artificial limbs and orthosis for bracing, customized drug delivery system, and even organ and tissue bioprinting in the very, very near future. For this lecture, we simply concentrated on our actual and personal experiences, that of anatomical modeling, patient-specific templating, instrument prototyping, and instrument production. As we can see, 3D printing offers a very wide platform for creativity amongst us surgeons and medical practitioners. There's only going to be one major setback when we talk about the use of 3D printing in patient care. And what is that setback? That is when we stop imagining as to what 3D printing can do for us in providing critical care to our patients. Thank you for allowing us to share our humble experience. I hope you were able to pick up an idea or two from what we have presented. Please take care, and we hope to see you face to face very, very soon. Bye-bye.